Of putting 0.2 and they got n to be like 6 or something crazy. What do you guys get? I don't care. I didn't ask about this problem, so if you don't get anything, it doesn't matter. Yeah, 3946 point stuff. So what's the answer? Yep, there you go. You got to make it whole people. You don't want to chop that last guy up.
So whatever.
Good last one. I'm sorry. Huh?
Whatever the decimal age, just round up, right?
Yep. And again, for those of you who are curious why that is, n has to be at least 3946 point whatever. If I make it go down, I'm not within 2% anymore. I'm within like 2.001%. So I force it to stay within 2 by making that go up always. It follows that rule of, if there's something I'm not sure about, I kind of punish myself. So I make the sample become a little bigger. If you don't understand what I just said, just always make that go up. Yes? You could, yeah, sure. It's on the practice test, right?
I'm actually going to ask you to do the problem for the type.
Like number 4?
Yeah, because it does ask to identify the type 1 and type 2 errors.
Oh, yeah. That's number 6, right?
Number 4.
But it goes back to number 4. Or
yeah.
no?
Oh, yeah. It is
Yeah.
number 6, but it refers to me.
Okay. So, like, real quick, this one. All right, right? For this problem, wasn't that those that we got, the hypothesis, right? The way I remember the errors is a type 1 is the smaller phrase. Reject a true null. Type 2 is a large. Fail to reject a false null. And again, there's only 2 things that we can get from a hypothesis test. Either reject a null or fail to reject a null. That's it. So how could we be wrong if I reject the null when the null is actually true? It makes sense. If I think he's wrong and he's actually right, it's my bad. So a type 1 error definition is reject a true null. Reject a true. So there's a lot of different ways to interpret this, but I kind of like to do what's the reality in this case? What's the reality? So we rejected it, but what's the reality? This is true. So in reality, the percentage is at most 75%, but we think it isn't. Right? In reality, P is at most 75%, but we think it isn't. And I think I told you guys the probability of making this mistake is alpha. So we can control this error by controlling what alpha is. How important is it to know that with the test? Not at all. But it's just good to know in general. That's what alpha really does. It's why it has different possibilities for the value, because it depends on how bad a type 1 error is. People could die. Oh shit, we better set alpha correct. Or, somebody's not going to get enough cookies. Well, then what the hell? Who cares? So type 2 is if I do what? fail to reject a false null. The guy's wrong, and we fail to think he's wrong. So fail to reject a false null. So the null is actually not right, but we think it is right. So in reality, P is less than 75%, sorry, greater. So that's wrong, but we think P is less than or equal to 0.75. We think the null is true, when in reality, it ain't.
So if you want us to write the opposite, could we just say, like, in reality, the statement P is less than or equal to 0.75 is false?
It's false, sure, but we think it's
And you want us to say the opposite?
But we think it's true. That's, without that second half, you're not showing me how it's an error. You're just saying in reality it's false. Okay, where's the mistake? Oh, but we think it's true. Ah, there's the mistake.
But you don't, it doesn't matter if we actually write P.
Like I said, there's a lot of different ways to write what I just wrote. You don't have to write exactly the way I did. Yes?
So type 2 be a false positive?
Oh, I love it. So I've always wanted to create, well, anyway, whenever you get tested for something, STD or something, cancer, right? There is a chance of getting a false positive, right? That doesn't quite fit in. Depends on the way you would set up the test, but normally you're looking for evidence that. So let's see. Let's break this down. I like this. If you go in to get tested, let's say get tested for cancer, so we don't have to talk about chlamydia or something. It's out there, kids. Careful. All right. What are they trying to find evidence for in that case? They go in to get tested. They're trying to find evidence that I have it, right? So the null hypothesis would be don't have cancer. And the high would be I do have cancer. So false positive would be if I reject this, but it's actually true, right? So let's think about this. What would a false positive mean? That means the test comes back and says that you have cancer, but in reality, you don't. So you can see how that falls in. Which type error would that be? In reality, you don't. So in reality, this is true, but the test rejected it. So that's this one, right? And there is a greater than 0% chance of that happening. In fact, false positives are more common than people understand. So this is kind of, should be a little bit, if you get a positive result for some horrible thing, you don't immediately freak out because there's a better chance that it's false positive than you realize. I'm not saying it definitely is, don't get me wrong. I'm just saying there's a better chance that it is than you think. So hopefully nobody ever has to go through that, but it's a little piece of hope to hold on to if you do get that, right? Okay. Does that make sense? I like that. So the whole idea of false positive is a type of error that we hear about. False positive is a type 1 error. We found evidence, yeah, anyway, okay. Found evidence against the null when actually it was true. Yes? No. This is the great thing. We don't know. Isn't it? This is the thing about statistics that people hate. I don't know what's really going on. I don't. I'm conducting a test. I'm going to go test the water to see if it's causing cancer. I find results. And if my results show it is, does that mean it really is? I don't know. I can just talk about the chances, the likelihood that it is. There are very few things we can prove 100%. And that's why statistics is so beautiful. Could be wrong. But if it's replicated, if another independent agency comes in and does it and finds similar results, it's even less likely that they're wrong, but it's still not 100%, and that's very frustrating for people. But I'm like, holy shit, math is not magic. You either hate math or you go, math should be able to figure out everything. It's like, no, somewhere in the middle. Between hatred and perfect is where math lives. I like that. I'm going to put it on my gravestone. Yes?
So, okay, you give the answer that says fail to reject,
Yeah, if your result is that you fail to reject the null, the only kind of error you could have made is a type 2. Right? Yeah. Okay, I like it. So you can write the 2 types of errors you could make, but if you actually conduct a test and get an answer, you know exactly which kind of error you could have made. Yeah, I like it. Good, good. Okay. Good talk, kids. Anything else about? That was fun. Until I heard the phone drop, I didn't know what had happened to you. I just saw them. All right, let me go ahead and give you guys the answer key. See what happens.
For the back of the one of the handouts you gave, the one with the Chicago police, were we meant to skip the back?
I just didn't have time to do it. That's another. You could do it if you want to. For extra practice, yeah. I thought you said superstitious. I'm not superstitious.
Just the extra credit.
A little stitious. The only place chapter 10 could show up is in the bonus. Because it's extra credit homework, I'm going to put a bonus question on there. But real quick, by the way, I did talk with my other stats class. You don't have to listen to me right now if you're not going to try chapter 10. Well, listen to me anyway. This is the formula for T star for one sample, right? Okay, and that is true. It happens a lot in real life. That's fine. But what happens even more often is, for example, if I'm going to test a new drug to see how it affects people, how would I set that up?
By failing class.
I'm going to test it. I'm creating a new drug, and I want to see what it does to people. I want to see what effect it has. How would I set that test up? I'm going to have how many groups?
Control group.
Yes, I'm going to have at least 2 groups. In reality, we have 3, but we're going to go with 2. I have one group that gets my drug, and I have the other group that gets sugar pill. Right? And everybody knows about the placebo effect. And that's just to deal with the fact that our mind controls our body, so there should be some connection between our thoughts and our body, and there's, good positive thoughts normally increases your immune system, all this kind of stuff. But, we do need some help, right? Anyway, I don't want to get into anti-vaxxers and all kind of bullshit. But, so this is for one sample. Oh my, flat earther, anti-vaxxer. Oh, that would be so, I don't know, I think I'd explode. So if I have 2 samples, watch what happens. I'm going to have 2 X bars. See? One group would be control, the other group would get my actual drug. So that's the 1 and 2 means.
Wait, placebo actually.
It doesn't matter, to be honest. Just one is one group, two is the other group. You can pick. And then there's going to be two means. The mean for everybody who would take my drug and the mean for everybody who would take a placebo. Right? And there's also going to be, now here's where things get really weird. Isn't this the formula for this, right? That's what Sx is, XX bar. Right? S divided by square root of n. Stay with me. Couldn't I write that like this? What's the square root of s squared? S. So now 1x bar, 2x bars. 1 mu, 2 mu's. 1 s, 2 s's. 1 n, 2 n's. All right, it's just everything doubles. So I still maintain that the c-square, z-square formula never changes, even though now you're like, dude, look at that monster. Wow. That's the formula that you would use in that chapter 10. I think I signed the one with t-scores on. No, if you wanna try chapter 10, you can put that on your formula sheet. I would not put that on your formula sheet if you weren't going to try out chapter 10, because then it's just going to freak you out when you're doing the normal test. But if you want to put that formula down, but one little adjustment I can make. What am I fighting against when I give one group the placebo and one group my drug? What do I hope doesn't come out of that? That my drug and the placebo have the same effect, that the means are equal. So most often these two will equal each other, so that would be 0. So the actual equation then is these two subtracted divided by this. Yes?
So,
And again, real quick, that is from the chapter 10, that I made extra credit. So if you're freaking out that I didn't spend a lot of time on that, I don't give a shit. You don't have to do it if you don't want to, but I thought I'd say a little bit of something in case you want to try it. All the steps of the hypothesis test in chapter 10 stay the same. It's just on step 4, you got to use that bad boy.
so would you ever see C-star in hypothesis with 2
So, of course, if I knew the if I knew the standard deviation of the population, if I knew sigma,
So would it be?
it would be the same thing just with sigmas instead of s's.
At the bottom.
Yes.
And then when you have 0 at the top, is that part of it?
Yes. So in reality, the formula is that. Because the mu1 minus mu2. The null hypothesis would be they're the same. And I'm trying to show that no, they're not. They're different.
Okay. So,
Okay. Anything else you guys want to talk about before we go in for a root canal? Okay.
What did you say?
Oh shit. Have we got this? The ones that.
Yeah.
Ailey, you have something to say? Alright. I just request to do a problem like this from a sample. What you got, Jeff? 201 people. We find average of 11.2 with the standard deviation of 3.87. Right?
Right.
You know, like, dude, you just made that shit up, so sure. Find the 90% confidence interval for the true mean. How many intervals are we going to make right now? It's not a trick one. So for those of you whose conclusion says we are 90-something% confident that the intervals, I'm like, you didn't make more than one. You made one interval. Stop saying intervals. This is a little pet peeve of mine. It needs two numbers to make one interval, because it doesn't make sense to be an interval unless you have a beginning and an end. I'll let it go for now. So what kind of problem is this? What I need to look at here, before I can even do anything, what do I need to check? True, and what do I need to be true for either one of those?
Standard deviation. Population.
No. In order to do anything, I need to know that the distribution I'm working with is normal. So am I working with the normal distribution? Yes. How do I know that?
Sample size greater than 10.
Yeah, n is 201, which is bigger than 30. Check. And now, how do I tell if I'm going to use z or t? Why do I use t? Yes. Sigma unknown. S is known. Right? And again, people see this and they say, well, he told me the standard deviation, so it's z-scores. Again, that doesn't make any damn sense. Which standard deviation? How did you know it was a sample standard deviation?
It says from
Because
the
it came from a sample, yeah. So I'm not going to use the letter S. I'm not going to be nice. Are you kidding me? You know me. Have you ever met me? You're going to have to tell from context. Is it a population standard deviation or not? In fact, if you can't tell if it's a population, it's almost definitely a sample, because that's what we normally know. If it was a population, I would be like, the population standard deviation is known to me, because that's not normal for us to know that. Okay, so now we know what the shit to use to do this. How do I figure out the t-score that I need?
area and two tails is 0.
Yeah, alpha is
Or 0.1.
0.10.
And then degree
Degrees of freedom
is 200.
is 200. I'm hoping that's on there. I think it is. You guys with me? Yeah, I am in the same room with you, Jeff. Yes. What level of confidence did I want? 90%. So what's alpha? 10%. In two tails. If you made it 5%, that would be in one tail, same column. Do I go all the way down to the bottom of that column?
No.
I want a t-score, so I better stop. I better stop at 200. Ooh, I get some dissension. So alpha's 0.10 in two tail. Stop at 200. Yeah, 1.66. I'm sorry, 1.653, right? You guys see that? Today's review day, so if you don't, it's a great time to ask.
How did you know the degrees of freedom?
What was n?
201.
And degrees of freedom is always just n minus 1.
Okay.
Or, for this situation, that's what the degrees of freedom are. Later, the degrees of freedom might change. If I'm in a different situation that we haven't studied yet. Yes?
And let's say n is like 89, or I'm sorry, like 88, and obviously it's not on the t-scores chart. Would you go to 90?
You technically should go to 80. But if it's that close to 90, I wouldn't take points off. You just, yeah. Remember, you technically always penalize yourself. So you make the t-score bigger,
Wait, it says bigger than.
which means make the n smaller. The smaller n is, the bigger t is.
Oh, okay,
Yeah.
yeah.
But if I gave you, if the n was 198, go ahead and use 200, yeah, right? I mean, at that point, it's not changing much, so what the hell? Everybody okay so far? Somebody's like, I haven't been okay in a long time, Jen. I'm sorry. I didn't mean to do that to you. All right. So what's the formula I'm going to use? Yes? Good start. X bar. Yeah, okay, good. And now I got everything I need. And that'll be on your formula sheet, so it's I got X bar. What's X bar? What's X bar? 11.2. Give or take. This many. S was 3.87 divided by square root of 201. Yeah, once you figure out the T or Z score, whatever it is, they pretty much have to give you everything else. Now, I could give you a problem. I think on the practice test, was it number 3? Number 3 was a confidence interval problem, but I gave you a list of data, so you had to use 1 bar stats to figure out X bar and S.
Yeah, so I think, worksheet that we did where everybody found their own confidence intervals and
Yes.
put it on the board.
Yes.
Is it kind of like that where like you have
Yes.
like a bunch of people and then you would use the N that's in the sample or like the
Oh, I wouldn't necessarily give you one like that. I would give you a list of data, so you just use whatever the N is.
is that in that one I got confused which N you wanted.
It's always got to be the N of what you're working with, which is your sample, not the whole you're not working with the whole population, so you can't use that N. And then, I don't know, whatever the hell that comes out to be. Is the error like 0.542? I don't know, I'm just making up those things. Okay. 0.45, 451? Okay. And then you just do that. Sure. I mean, all that is, the only difference between if I gave you a list of data and it said construct a 90% confidence interval, first off, I'd have to tell you, what would be one thing I'd have to tell you that I didn't have to tell you over there? Normal, yeah. Since the sample size here is definitely small, I'd have to tell you it's normal enough, like it did in number 3. Yeah, so I'd tell you it's normal. And instead of me just telling you what X bar and S are, you just plug it in the calculator and figure out what X bar and S are. And then it'd be exactly the same thing we just did. Right? So the only difference between this kind of problem and that kind of problem is I tell you X bar and S, and over here you just plug it in and get X bar and S out of your calculator. The actual work after that is the same. Get the degrees of freedom, look at the t-score, blah, blah, blah.
How would you know what?
Yeah.
However many days.
Shaboom, I can see.
And that's when it's like a step further, but it's the same problem, but it's just
Yeah, your first step on this problem is 1 bar stats. So you can catch up to that problem. I can see the X bar and S here, I better put them in, and then I can see the X bar and S. Confidence intervals. Can everybody do something in the air that shows me what a confidence interval looks like? Yeah, okay. Boom! Yeah, I just created 2 tails. So confidence intervals are always 2 tails. Chop, chop. Right? That's why when we first got the T-chart, it was for confidence intervals. We only looked at that second row because there's always 2 tails. Yeah. which would that be a sample or a population? Well, I'd have to tell you, but in the context of what the question was, that would be a
That would be
sample.
a sample, so you would use S.
So I know the calculator lists both because it doesn't know what you put in. We know it's a sample, we gotta use S.
And the other one would just be population.
If it was a population I just put in, then I'm allowed to use sigma. Yeah. Yes.
So why did you write 11.2 plus or minus 0.5?
What part of that is not? What was X bar?
No, because like I is that like the answer to 1.6453 divided like?
Oh, the 0.451? I'm sorry. Yeah, that's what this is. I think that's what somebody told me. Nobody said
Oh,
no.
because yeah, I plugged it in. I didn't.
Uh-oh. All right. That was close to what I tried to get in my head. I got pretty close though. Not for a math boy. I'm sorry.
So like, would you write out the confidence interval to complete that? Like since it's
Oh yeah. You have to subtract that,
Yeah. Okay.
and that we are 90% confident. Blah blah blah.
Then, for this kind of problem, would you want us to find the p-value again?
P-values come from what kind of problem? Hypothesis tests.
Oh, okay.
The p-value wouldn't have any place here for confidence intervals.
When you look at 2 plus 5,
What's it say?
it says we asked 89 California eligible voters if they voted in.
Oh, okay. So that's the p-hat confidence interval.
Yeah, just to check to see if the distribution.
Oh! Yeah, so, not to make, so everybody had a problem like this. From a sample of 78 people, we see that 60 say they voted, right? So what do you have to check to see if this is normal enough? Not n greater than 30, that don't mean shit. N times p hat, because we don't know what p is, so what's p hat? I was hoping somebody would remember n p hat is freaking